Hi, I'm Priya Chakrahborty. I'm a professional researcher with the Plug-in Hybrid and Electric Vehicle Research Center at ITS Davis. And today I'm going to talk about how electric vehicles, including battery electric vehicles and plug-in hybrids, are being integrated into household fleets. Primarily, how are they being driven in a multi-vehicle household where there's a mix of gasoline cars and these plug-in electric vehicles. So plug-in electric vehicles are more expensive to purchase than conventional fuel cars like gas or diesel or regular hybrid cars. But what they offer is fuel cost savings. So they are recommended to households with higher travel demand who drive a lot, and they're going to potentially get a lot more fuel cost savings. And it's not just like cost savings at the individual level, but higher electric miles also imply higher greenhouse gas emission savings. The primary goal of this entire effort of electrification of the light-duty vehicle fleet. So, but the evidence about how much PEVs are being driven or how they're being used in terms of vehicle miles traveled has been pretty debatable so far. So, like some of the recent studies have shown that PEV drivers are not using these cars as much as ideal. So, what we try to do in this study is try to figure out like why these results, why we see these results, how are the PEVs being actually used. And we do this by looking at multiple surveys and then eventually modeling the usage of a PEV in a multi-vehicle household. We start off by looking at 3 survey data. One of them is the National Household Travel Survey that was done in 2017, with the sample being collected primarily in 2016. The problem with that, or the issue with that survey, was that it primarily captured first generation battery electric vehicle owners. And with single odometer readings, limited number of PEV households, what we usually get is going to be different from the other 2 surveys that include the California Vehicle Survey that was administered in 2019. Though it had limited number of battery electric vehicles, it had it had a higher share of newer PEVs like the Tesla or the Chevy Bolt. Those are not just newer, but also longer range BEVs. What we'll focus on eventually, and we also use in this comparative analysis, is the UC Davis EVMT survey data collected, a survey that's administered by the PH&EV Research Center, as well as onboard recorder or the logger data that's also collected by the PH&EV Center, and see that how these plug-in electric vehicles are being used in this by PEV owners in this sample. This has been done in 4 phases, starting from 2015. It has got not only a lot more PEV owners, because it is a cohort survey, but it also has fair share of not only first generation BEVs, but also more recent long range BEVs. So when we compare the data from these 4 sources and estimate the VMTs, so when we compare the VMT estimates for these 4 surveys, what we see is that like compared to the NHTS data that captured primarily first generation battery electric vehicles, the VMT estimates from the other 3 surveys or data sources are much higher. PEVs are being driven on an average 13,000 miles, as much as the gas cars that are in the sample. So when we use data like that has a higher share of the older generation PVs, we may actually end up with lower estimates because we're capturing these short range PVs or early adopters who tend to have larger household fleet and may actually not drive a particular vehicle a lot. So why does this matter? In addition to greenhouse gas emission savings, we care about how much the PVs are being driven because, like conventional fuel vehicles, it is important for assessing travel demand. There is fear that there might be rebound effect and the negative externalities like congestion associated with it if people drive these cars more because of the lower fuel cost. It is also important to understand PV usage and quantify VMT because it has an impact on road damage and, as I mentioned before, congestion associated with automobile usage. And finally, it also matters because it impacts the electricity grid because these vehicles have to be charged using electricity. So after the comparative analysis, we focused on using the EVMT survey data to look at how PVs are being used in single and multi-vehicle households. So here we focus on multi-vehicle household because that's where it is pretty interesting because we have the mix of gas cars and these plug-in electric vehicles. So how we do it is we split the total household VMT into the miles traveled using what we call here the PEV main and the rest of the vehicles in the household that may include other PEVs, but it's a very small share of the sample. So the PEV main is here the plug-in electric vehicle that may be a battery electric or a plug-in hybrid that was tracked in the first, there were basically 2 rounds of surveys. So we have the 2015 to 2018 survey, the EVMT survey, as I mentioned. And then in 2019, we went back and contacted some of the respondents who had given permission to do so and got a second odometer reading for the plug-in electric vehicle that was studied in the first round of surveys. So here we have 2 odometer readings and of the plug-in electric vehicle, and we call that the PEV main, the one that was recorded in 2 rounds of survey. So for each of these vehicles, we know their characteristics like vehicle model year, how long they have been owned, and other associated characteristics. We know what kind of charging opportunity these households have, like whether they have a level 2 charger at home or not, where they live, so built environment characteristics. And we also collect data on their attitude towards technologies like the plug-in electric vehicle, or as well as their lifestyle preferences, like whether they like outdoor activities or if they like suburban living, etc. And the choice of the model was such that we could account for the fact that the total household VMT and the VMT of the plug-in electric vehicle were correlated because one is just a share of the PV VMT is just a share of the total household VMT. So what do we see as the main results here is the share of VMT in a BEV household matters depends on the electric range of the car. So if we have a higher electric range, then the BEV has a higher share of the total household VMT. It also measures the cost of operation of the other vehicles in the household, and the share of PEV in total household VMT goes up if the cost of operation of the non-PEVs is high. That is, you have less fuel-efficient vehicles in the household compared to the ones that have, are in general, more fuel-efficient. It also depends on the home electricity rate, we do not have data on like how much they use public charging or what is the cost of workplace charging. So what we could track here is the household electricity rate. And we see that if the electricity rate goes up by 1%, then the share of VMT by plug-in electric vehicles reduces by 2.1%. It is, though it may not capture the full price sensitivity of a household, but considering how home charging is the primary place for charging these vehicles, we can see that household electricity rate can play a big role in how much EVs are driven. And older BEVs have a lower share in the total household VMT that can be driven by their lower range or age of the car. In terms of household VMT, it is the factors that we have seen before in the literature that matter. Basically, a larger fleet leads to higher VMT in total and a lower share of PEV VMT in the household. The age of the household fleet matters, and it's not a linear, but a non-linear effect is what we see. In terms of lifestyle preferences, we see that if a household likes to do outdoor activities or suburban living, it tends to raise the total household VMT. Built environment factors matter, and if you are in a dense neighborhood, then you tend to have a lower VMT, or if the neighborhood has a high walkability index, primarily that it is suitable for walking, biking, then you tend to have lower household VMT. So the main takeaways from this analysis is that PV technology is changing very fast with more longer range BEVs entering the market. So we have to be careful as researchers and policymakers on what data we use to estimate the VMT. What we have seen so far from surveys or data that has a high share of the newer EVs, that they tend to be driven as much, or the VMT is comparable to that of a comparable ICE vehicle. And in terms of the factors that influence VMT, we see that the regular factors that have so far been identified in the literature, like built environment, population density, or walkability of a neighborhood, as well as lifestyle preferences, does impact not just the total household VMT, but as well as the plug-in electric vehicle share. But in terms of the PEV in particular, range, electricity price, as well as vehicle age will influence the miles traveled using the plug-in electric vehicle. Thank you. And it was a pleasure presenting you my research on this topic. And the collaborators on this project was Scott Hartman, who was also a professional researcher with the Plug-in Hybrid Electric Vehicle Research Center, and Gil Tal, who is the director of the research center. Thank you.